Welcome back to the our session of uh, session 6. A warm welcome to the session. So, friends, till now, from the past 5 days, we have gone through the introduction of R, and after that, we have dealt with the variables, the data types, and the operators which are present in the R. And the next day, we have dealt with the vectors. The next day, we have seen about the different conditional statements and what are the different loop structures which are present in R. And in yesterday's class, we have looked into the different functions and how the functions are useful for us. Means like if you're talking about the reusability, how the function concept is very, very useful for us. It's a kind of building blocks for a basic building block in R programming, right? And friends, when we're talking about like the next topic is, so till now we have seen the different, like how to make use of the functions, the conditional statements and all, and how to mix and match, in the sense like we can use conditional statements along with the functions, right? Now, so we have just got a basic idea about like what are the different things what we have in R programming. And friends, in today's class, we'll be learning about what do you mean by analytics, right? So friends, just want to know what is your opinion? What is the basic meaning of analysis? Anyone, friends? So if you're talking about the analysis, means here whatever may be the data, that may be a CSV file or maybe a JSON file or a picture, whatever it is, whatever you look into data, what you have collected, okay. So from that, what you're able to analyze, what is the insights you have got from the data is what we'll be considering. And based upon that insights, we'll be looking into further and we'll be predicting what can be the future outcomes, right? Now, friends, when you're talking about this analytics, here we have 4 stages of analytics. Okay. Now, so before moving on to the analytics part here, friends, here till now we have seen how to, in yesterday's class, we have seen about this, how to install different packages. Okay. And like we have seen like how to go with the data. We have different data sample data is there, and also how to load these data frames and how to work with the different data frames. So this is what we have seen in yesterday's class, right? If you can remember. In today's class, we are left with the data analytics, and we are left with the topics like data transformation, and we're left with the topics like data visualization. So these 3 topics we'll be covering in today's class. Right, friends? Now, when we're talking about this analytics, right? So let me give a small example. I'll not take much of time. I'll just give a small example, friends. If you're taking a data of, say, PlayStation 5. Let me take my pen, friends. I think you all know about the PlayStation 4 and PlayStation 5, right? PS5. Okay. So PlayStation 5 is it's a game which like most of the kids, maybe right from age 11 to 25 or even more than that, on rough and average, they'll be preferring playing with this PS5, right? Now, so there is a company by name XYZ company, right? And this XYZ company is into this, they are selling, means they sell this PlayStation, different PlayStations, maybe PlayStation 4 or PlayStation 5, or maybe any advanced versions, or maybe any AR related, augmented related games. Okay. Now, what they want us to do is they want us to analyze the data. They're asking us to analyze the data and what will be the profit in the forthcoming months. What can be the profit in the forthcoming months, right? Now, friends, If they want us to analyze the data, then how can we analyze the data? Means how can we know what can be, because we cannot say what can be the future, but how how to tell what can be the sales in the month of maybe January, or means like maybe forthcoming months. As of now, it is February. What can be the sales in the month of June? How can we predict that? We have a solution for that. We are going to collect the data. Okay. We are going to collect the data, and based upon the data, we will be we'll be looking into the data. What is the data we have from the past few months and how the data trend is being going on. So based upon that, we'll be analyzing it and we'll be coming with a conclusion. Okay. So here, friends, what we have here is the different stages of analytics. Okay, we have four. Okay, let me erase the screen, friends. Here we have 4 stages of analytics. Okay, so first one we call it as descriptive analytics. Second stage is called as diagnostic analytics. Third stage is called as predictive analytics. And the fourth stage is called as prescriptive analytics. So what is this descriptive analytics? What is this diagnostic? What is this predictive? And what do you mean by prescriptive analytics? So when you're talking about this descriptive analytics, guys, so here we are dealing with what happened in the past. Okay, it exactly means what happened in the past. That means here we are dealing with the data. Maybe from some months back or some years back, and how were the sales maybe a year back or maybe some months back. So that is what happened in simple sense. I'll say what happened in the past, right? We're talking about the PlayStation 5. So what happened in the past months, and what were the sales and what are the profits, what we have attained in the past months. Okay. The second thing, here we have the diagnostic analytics. So what does this diagnostic analytics means? The diagnostic analytics means we are going to diagnose, just like how the doctor diagnoses the diseases. So here we are going to, based upon that, the data what we have attained from the descriptive analytics, we are going to analyze that, and that is what that diagnose that. So it comes under the diagnostic analytics, which means why did that happen? Why and how did that happen? Okay. Why and how did that happen? Got it, friends? And now comes the predictive analytics. In the predictive analytics, we based upon the what happened in the past and why and how did this happen? Okay. So based upon these two factors, we will be comparing them and we will come up with a solution. What can be the future? That is what we are predicting. We are predicting the future, right? So that will be counted as a predictive analytics. So what will happen in future? What will happen in future? Okay. And next, let us say the future is fine. It's good. Means like if you're going to get a good sales, and let's say if our prediction is good and it is giving us a result like the sales might increase in the forthcoming months, then it is fine. But still, that has to be continuously evaluated. If not, if there is any drop in the sales, then what has to be done? Just like the doctor prescribes a medicine to the patients. So same way, we are going to prescribe some methods. We are going to prescribe some methods. What can be the, what methods has to be implemented so that we want to increase the sales. let me give you an example. I'm just going with the same example here, guys. So when you're talking about the PlayStation here, PS5, so when you're talking of the first descriptive analytics, so what happened in the past? So when you're talking about this, so in the past, let us say the month of November, December, okay, and January, the sales were constantly increasing. Let us say if you're taking the curve like this, the sales were constantly increasing. Okay. And this is the first one. That is the descriptive analytics. And the second one, the diagnostic. The diagnostic analytics. Here we are going to see why is that curve increasing? Means why the sales graph is going to the peak? The reason might be, friends. So most of the PlayStations are being used by the people. Means like the users. If you're talking about the users, friends, who are the users here? The kids and the adults, like young adults who are age maybe from 11 to 28 or even more than that. And who are the customers who are going to buy these, friends? The customers here, the parents or maybe grandparents who are going to buy those gifts to their family members, means to the kids who are gifting them, right? So why it is in the peak in the month of November, December, and January? Because in those months we can see we have the Halloween, means like we have the Halloween, the Thanksgiving Day, and after that we have the Christmas, and all the celebrations will be going on in those months, right? So that is the reason why the sales are going to the peak in those months. Fine. So that is what we have analyzed. So that is what the first two steps, that's what we have analyzed. And the third one, we are going to predict what can be the sales in the month of, let's say, now we are in the March, April, and May. So what can be the sales in these 3 months? So as per like if you're going to predict it, maybe there may be a dip in the sales, because in these 3 months it is like we have the examinations going on for the students, so maybe they not concentrate more on these games, so there is a drop in the sales. So that is what we have analyzed. Now we have to go with the prediction, means we have to go with the prescriptive analytics. What is the prescription for this? We don't want our sales to go down, friends. That's what, right? So we need to increase the sales. Then what has to be done there? Quite simple, we'll have to attract the sales. So what is the prescription? So here also we'll be going with analysis, like ABC analysis. Means we will be doing analysis both on the users as well as on the customers. Users means on the kids, so how to attract the kids, and the customers means how to attract the parents. Maybe it might be coupons, or maybe some sales discounts, and all these things we'll be applying them, and we try to maintain the sales. May not be to the top, but try to maintain it to some extent. So friends, this is how the analytics happens, right? So for all these things, what we need, friends, we need data, right? So we need data, and based upon the data only, we will be doing all the manipulations, friends, and we'll be getting all these sort of answers, right? Now, so let's say we have got the data. Okay, we have attained the data. And friends, remember, the data what we collect might be from the companies, or might be from the websites, or might be from different sources. Like when we are approaching the people, and we are taking the data randomly from the people also. Remember one thing, the data will never be clean. Means the data what we are attaining is a raw data, and we need to clean the data. Until and unless the data is in the clear form, we cannot apply the statistical models to that. Why? Because it's just like yesterday we have discussed, if you are going to apply the statistical models on this unclean data, what happens? You will never get the accuracy. No statistical model will be working properly. We'll get unwanted results. Okay, so in order to avoid that, what we are supposed to do? We are supposed to clean the data. Okay, friends, so how are we going to clean the data? So we have different techniques. We need to follow those techniques, friends. So then only we'll be able to get a clean data and we can apply our statistical models on that cleansed data. Okay. Now, friends, in yesterday's class, we have seen about. Okay, let me take my pen. Yesterday's class, we have seen about. Just give me a moment, friends. Yesterday's class, we have we talked about the first business movement, first moment of business. Second moment of business. Third moment of business. And fourth moment of business. Okay, so in these things, what we are going to do is we are going, in the first moment of business, we are going to check whether the data what we have is in the standard normalized form. That means here what we'll be doing, here we'll be checking with the central tendency. Okay, the central tendency again here comes with the, we'll be dealing with the mean, median and mode, three things. And the second business moment, here we'll be dealing with the variance and standard deviation. STD stands for standard deviation, friends. And in the third business moment, we'll be looking for the skewness. And in the fourth business moment, we'll be looking for the kurtosis. Okay, friends. So this is what we'll be looking for. And when we just go through all these business movements, what happens is we'll be coming up with some solution that there has to be, like, there are some discrepancies in the data and which needs a data transformation. That means we need to do some data transformation. Right. So when we are going with the, see friends, so this is a normalized, that's what we call it as a normal curve which should look like. And for this, when you say it is a standard normal curve, not standard normal graph here. So in this, the mean should be equal to, median should be equal to mode, and all the values should be equal to 0, which should be lying on the center. And the complete area under the graph should be equal to 1. Okay. Area under the graph should be equal to 1. And if you're talking about the standard deviation, that should be also should be equal to 1. So remember, friends, so these are the important questions. Generally, the interviewer will be asking you, that is mean equal to median is equal to mode should be equal to 0. And the area under the curve should be equal to 1. And the standard deviation should be equal to 1. These are the minimum requirements for a standard curve. But what are the curve? Means, see, we have the data. Okay, so when you're plotting the data set, we will never get a graph like this, which is nearly equal to a standard curve what we have. So in order to, means we might get our curve, a graph like this, which is a skewed, or sometimes so this is what we call it as a skewness, means which is shifting towards your right side, a left hand side, means we can say it is a positively skewed, and this is a negative skew. Likewise, okay. And sometimes when we are talking about the kurtosis, so kurtosis means platykurtic. We have 3 different types of curves. Actually, the standard curves should be having a kurtosis value should be equal to 3. And if we are getting the kurtosis value more than 3, we call it as a leptokurtic. Okay. If we are getting the value less than 3, we call it as a platykurtic. So these things have to be kept in mind, friends. So when we want all these things to be avoided, and when we want our data to be clean, and for those purposes, we means like if I want our data to be clean, then we have to go with the transformation techniques. That's what we call it as a data transformation. Okay. So friends, what is this data transformation? So data transformation is a very crucial step in our art programming, whether it may be art programming or if you're dealing with the Python or wherever it is. When you're talking about this data analytics, the data transformation is a very crucial step, the data science workflow. And it is a very, for this, we have different data transformation tools, which are very powerful. we'll be using those tools for achieving the data transformation. So let's see why the data transformation is very important. Let's have a look into that. Before that, let me erase the screen, friends. Let's say why data transformation is important. Why the data transformation is important? Why? Because when you're preparing the data for analysis, okay, when you're preparing the data for analysis, so that it is going to improve the accuracy of results. So what are the results what you are getting that's going to get improved when we are going with this data transformation? The second point is like, see friends, whatever may be the data set what we have here. Okay, let's say this is your data set. Okay, in the data sets we have different columns. Okay, in yesterday's data set we have seen the GMAT score. Okay, work-X, and in another here we have seen the data roll numbers. Likewise, so we have some data here. So this is the column data what we have, and each and every column, the numbers what we have will be considered as the variables. Okay, and each and every column, when we are comparing each and every column, there will be some correlation between the columns. Okay, and also sometimes there will be some, what we say, like hidden patterns between the variables what we have in the data sets. So when we are going with the data transformation techniques, this data transformation techniques is going to unveil any, if there is any hidden pattern between those variables, that will be taken out. Okay, means we can unveil them. We can just get the patterns which is being followed by those variables. And also friends, how means like we have to be very, very like how far you're going to squeeze the data. Means we have to squeeze it, we have to wrangle it, we have to be very, very harsh with the data. How far you're squeezing it, that much means like that much will be clearer your data will be. Okay, you have to cleanse it in such a way that you have to go through all the data transformation techniques, all the data transformation possible to get a clearer data, and based upon that we can work with the statistical models. So that is what is our aim. Now friends, when you're talking about this normalization techniques, so our data should be equal to the normalized curve. So then only you can say it is a kind of pure form of a data. Okay. Next is like the third point is like okay, let me take a pen. Okay. So second point is unveils the hidden patterns. Third point is if there is anything like it enables specific analysis. If there is any like on particular column, if you want to do any analysis, so the data transform will be helpful for us. Okay. And next is like it enables the it improves the efficiency also. So likewise, this is the importance of the data transformation, friends. Okay. So under the data transformation, we have different techniques we'll be following. Okay. So let's see what are the different data transformation techniques we have. Let me erase the screen, friends. No. So friends, I told you in yesterday's class, like we have some sample data. Sample data sets are present in your R programming itself. So when you're typing the data and with the close parentheses, you can see here. So when you type it like this, so when you type data and when you run this, you can see we have some sample data sets which are available for us, and we can use those sample data sets means by chance if you don't have, just for our practicing purposes. Okay. So I have taken a randomly have taken a data set called by name iris. So this iris is a data set which is related to the flower. Okay, so we all know that what are the different parts of a flowers, friends? We have the sepal, we have these like petal length, we have means we have different parts in a flower, right? So in this means based upon that the length of the petals and the length of the sepal and the length of the complete cord, we are going means this iris flower is having different species. It has different species, and we have to analyze which species it belongs to. Okay, so this iris dataset is regarding the flower. Okay, as of now, just remember that. And in today's class, we'll be working with the iris dataset, friends. So for data transformation techniques, we have to follow the library, which we call it as a Diplor. Okay, we have the name. So we have to import this library, friends. Then only we'll be able to run our program. Now I've taken the data. See, you can see here, I have loaded the data iris. And here what am I saying is I'm taking the, we are going to arrange the sepal length in an ascending manner. So this is one kind of a transformation technique. Okay. Now let me run this, friends. Okay. See, what are the data sets? Like, see, you can see the data frames which has been coming here. So when you either you can click on this, or else if you want to have a look at the data which has been arranged, just write it here, iris underscore arrange. So this is what the name we have given there, right? So when you click on this and when you click on run, you can see how beautifully it has been arranged in a, you can see here, friends, the console window. So it has been arranged in a ascending order. Okay. So first and the foremost thing is when we are working with the data, sometimes we need to sort the data set also. So here you can see it has been sorted out in a very easier manner, just with a one keyword, friends, arrange. Okay. We have used a one keyword called as arrange, and based up, and we have given the name of the data set, that is the iris, along with some symbols, that is the percentage is greater than percentage, and this has arranged our complete data set in a ascending order, friends. Now, if you want to arrange the data set depending upon the sepal length, okay. So here also we are going with the sepal length. Along with that, if you want to arrange the data set as per the species, so that also can be done. But here we are going in a descending manner, friends. So that is the reason why here I said arrange, okay, and I haven't given any ascending, but here I'm just using the word descending here, friends. So which means the data set has to be arranged in a descending manner. Fine, friends. So when I'm running this and I'm like executing this, you can see we are going with the sepal length, right? So this is a sepal length, friends. See, it has been arranged in a descending manner. See, 6.4, 6.3, 6.2, likewise, 5 point, and it has come to the 4.3. Yes or no, friends? Isn't it very easy? Yes, it is very, very easy, friends. Right? And now, friends, we have the iris selected. Okay. And what does this do? So here, if you want to go with this, select any sepal length, and we can just go with this. Okay. And if you want to execute this, just type the iris. If you want to see the output, and you can just type the selected. Okay, so we have selected only the sepal length as well as the sepal width. If you want to have a look into this, just click enter and you can run this, friends. So we can see, so instead of all the columns, so previously we were having a You're having different columns like the sepal width, the sepal length, the sepal width, petal length, petal width, and species. So instead of that, I just want only the selected columns. Sometimes, friends, all the columns are not required when we are going with the data transformation, right? So at that particular time, whichever column we are interested in, so for that particular column only we'll be looking into. So as of now, my interest, my region of interest is on sepal length and the sepal width. So when I've given there the sepal length and sepal width and I've executed that, you can see the result here. I'm getting only the two columns as an output. Got it, friends? And next is select the column starting with the name sepal. Okay, when you're going with the name sepal, so this is going to give me the output with the name as sepal. Oh, I think we got some error here. Okay, here you can see you got the output with the name, which is having the sepal length and sepal width. Okay, friends. Now, here, let me ask you a question, friends. Here we have the iris filter. Okay, here we are going with another data transformation technique. That means we are using a filter. Sometimes we don't require a few like columns, or sometimes we'll be like filtering some variables from that. Let us say if you are going with a, what is the filter being applied here? Sepal length greater than 5.5. Now, friends, I'm asking you a question. Okay, we have a chat. Just answer me in the chat. What will be the answer if I execute this? What will be the answer if I execute this, friends? Let me know in the comments. If I'm using this transformation technique for the filter, what will be the output, friends? I need an answer. Simple. The sepal width. Okay, so here I've executed with the sepal width sepal width greater than 3. So that will be executed. You can see here, friends. I have executed this line. Okay. So here I'm filtering this sepal width, sepal dot width, which is greater than 3. So that will be executed. If you can see from here, the sepal dot width, which is greater than 3, all the values will be executed here. And if you want to sort them out, you can write it. You can write one more line that you can go with the either ascending or a descending order. Got it, friends? And here in this case, if I'm executing this, so this is going to give me the output as sepal length greater than 5. So you can see the sepal length here, which is like greater than 5. Sorry, greater than 5.5. Not 5, it's greater than 5.5 will be displayed here. All these values you can see here. The sepal width, which is greater than 5.5, has been displayed here, friends. Okay. So this is how we will be using the different filtering techniques, friends. And now here, friends, we have one more technique. If you want to add a new column or a new row, new column into the data, means like from the given, means we have certain columns are in the data set. But if I want to add a new column, is it possible? Yes or no? Yes, it is possible, friends. So how to make it possible? Very simple. Go with the keyword called as mutate. Okay. So friends, here I'm giving you iris. Okay, so I'm going with iris.mutate is the name of the data frame what I'm using here, and I'm giving the command as iris. Okay, and I'm giving this as mutate. Okay, so just let me take my pen. When I say mutate, so what is this going to do is it's going to like add 2 more columns. Okay, it's going to add 2 more columns, petal length and petal width. Okay. Now we are going to add a new variable, to this iris mutate. Okay. In similar lines here, here also we are going with iris mutate 2, where we are going to add the sepal length is greater than 5. If the sepal length is if the sepal length is less than 5, we are going to say it is a short. The sepal length is greater than 5, we are going to say it is long. It is less than 5 short, it's greater than 5 long. So we are going to add 2 more columns to this. Okay. Now let me check. And one more thing, friends. So we'll be circulating the attendance sheet. So today is the last class, friends, for your R programming. We will be circulating the attendance sheet. Please don't forget to write your name and submit it back to us. Now, what am I going to do here is, let me execute this. Okay, we'll do one thing. We'll execute right from here. Now, let's see what happens. Okay. So when I executed this, friends, previously we were having only see, this is what the data set which was previous. Okay. Till species only we had the data set. We had the columns by name, sepal length, sepal width, petal length, and petal width, along with the species. Only 5 columns were there in the original data set. Right now, I have added one more extra column. That is what we call it as a mutate. We'll be using the word mutate, friends, for adding a new column here. So what does this new column do? So, so based upon this sepal length, if the sepal length is greater than 5, what it should do? It should give me in the new column, it should show that it is a long. Okay. When the sepal length is less than 5, friends, what should be the output? Yes, it should be short. Okay. Now, we can see here, if you can check here, the long and short, depending upon the different the things we have, is showing us the long and short. Okay, friends. That means the petal length. So we have created one column here. Now, if I want to group the sepal length along with the sepal mean, means I'm taking the mean of the sepal length, okay, and I want to group it. I want to just take it as a group. Then what is that? I have to use a keyword. I have to go with the keyword as group by and summarize. Summarize is for mean, and group by is going to group all the thing, means it's going to group and it's going to give me the answer. Okay, when I execute this, see, friends, here it's going to give me the 3 species what I have. That is a setosa, versicolor, and virginica. And here, what are the mean values? Mean value of the sepal length. If you're taking the sepal length column for the 3 different species what we have, what is the mean value is getting displayed here. And everything is getting grouped into only 3 columns, okay? 3 rows and 2 columns. We are grouping them. Okay, so this is how by using the keyword call as group by, we can group all the species. Okay, we are grouping the species here, and by summarize the mean of the sepal length, that's going to take the mean of all the sepal lengths what are present in all the 3 species together, and that's going to give me the. Got it, friends? So these are some transformation techniques we generally use in our programming. Okay, friends. Now, so now let us say we are done with the transformation techniques, and let us say my data is clean, somewhat clean. But do you believe that after this transformation is done, still the data is clean? We cannot say. Why? Because sometimes there is still some hidden, like sometimes we'll be having some hidden hidden impurities in the data. Okay, so how to clear them, friends? Very easy. We have, it's very easy. We have like another technique, what we call it as data visualization. So what is this data visualization? The name itself suggests says that visualization means we are seeing the data in terms of charts or maybe in terms of a pictorial representation. When you look into the data in terms of whether the charts are pictorial representation, from there also we can get some insights. Insights in the sense we'll be getting some idea whether the data is clear, clean or not. Got it, friends? So here I can say, along with your data transformation, your data visualization techniques also plays a very crucial role in cleaning your data. That is a processing your data. Okay, friends. And in the means it is very important in the field of data science or maybe data analytics that we need to clean the data intensely. We have to cleanse it, we have to wrangle it, we have to squeeze it, whatever the things you want to do. You have to be very rough on the raw data so that we can extract as much of data as possible, and we should be, and the data what we extract should be in a very cleansed form. Okay. And when we're talking about this data visualizations, friends, the R tool is having a very powerful data visualization tools. Okay, we are having a very powerful data visualization tools compared to a Python. In this way, your R excels. It is on the top compared to your Python. If you look in the data visualization techniques in the Python, it's normal. But in the when you're talking about R, it's entirely different. We have different tools and we can change the colors, we can add different features, and many more things are available in R programming. Okay, so why is this important? So when you're talking about the importance of the data visualization techniques, friends, here, this data visualization technique is going to give you the enhanced understanding. When you're taking the data and when you're taking it in a pictorial form, you'll be able to, that is improving our understanding. Okay, enhanced understanding. And sometimes raw data can be challenging, friends. Sometimes you cannot understand the data. So when you're placing it in maybe in the form of a map or maybe in the form of a chart, then only we can understand, friends. And the next is the tools in R. When we're talking about different tools in R, it is very wonderful tools what we have in R programming, and it is a very effective way for communicating. When you visualize the data and when you put all the data together, it's very easier for us to identify what is a mistake, means what is a thing where we need to improve, and it is a very good way to represent the data. Okay. And next we have the EDA, that is what we call it as a exploratory data analysis, friends. So when you're talking about the exploratory data analysis, I think most of you all have gone to the exploratory data, might have been having some idea. So who are having an idea on exploratory data analysis, please post it in the chat. So what is exploratory data analysis? Here we'll be understanding what is a business problem. And after that, here we'll be understanding what is the data what we have and how to clean it, and what are the different outliers which are present there and how to clean the outliers. Okay, yesterday we have discussed about the outliers. So how to clean all the outliers. So all these things will be done in the data transformation and data visualization. Okay. So friends, when we are going with the data visualization here also we need to download the library files. We need to download the data visualization tools, that is the library files. So here we are talking about the library file. What we have is the ggplot2. We need to download this. And likewise, we have different libraries. We can have a look at here the packages what we have. Sometimes we need to download them. Okay. So let me execute this, friends. And here also I'm going with the iris data file. Okay. So when I'm executing this, I'm going with the basic scatter plot. Okay. So when I'm running this, friends, you can see how the data is being scattered. Means like all these points means these are the different, like if you're going as per the sepal width on the y-axis, on the sepal length on the x-axis, if you're plotting the different variables on that, can you see, is there any correlation between them? I don't think so. Means I am not getting any answers, and what chat is being, I cannot see any chat here. Anyhow, friends, let me take my pen. So if you can see, is there any correlation? Means are you able to draw any line, and we can be like, can we relate like there is any relation between these scatter points? No. Then what we have to do, we have to go with the data transformation techniques. So what, see, just by looking at this graph, you are able to identify that there is no relation between the points. Means there is some missing relation in between the points what we have plotted in the scatter plot. So likewise, when you're plotting, we'll be getting some idea. We'll be able to understand the data. So that is the use of this data visualization. Means when we are plotting in terms of graph, we'll be getting some clearer idea compared to like just when we are going with the numbers. Okay. So numbers is fine. We'll be getting some number values. But apart from that, when we are going with this visualization techniques, it is much more clearer. Right? Now, friends, again, here we have the group by, and here when you're going with iris and summarize, and maybe going with this title. Okay, let me run this. Okay, fine. It's okay. It was part of this. Okay, fine. So let us then, when you're going with this histogram plot, friends, here we have the histogram plot. Just give me a moment. It's loading. So if you want to go with the histogram plot, so what is this histogram plot is giving us the insight. If you are having a clear look at this see, actually your plot should be somewhat like this. Okay, so here we are going with the frequency versus the sepal length. Okay, your plot is not much, means if you can observe, you're just putting all the points together, and if you're drawing this like this, it's kind of a platykurtic curve. The kurtosis, if you're calculating the kurtosis, you might get the kurtosis value, it might be less than 3. It's kind of a, see, the tail length is less here. Okay, this space is more. It's not like the standard curve what it should be, right? So here also, just by looking at the histogram plot, we can say that there is some discrepancies in the data. Okay, now, and let me erase this, friends. And yes, here we have one more plot, what we call it as box plot, friends. So when I execute this, so friends, this is what we call it as a box plot. Okay. So when I'm executing this, friends, what is that? What is the insight you can get from here? If you have any outliers in the data, so that will be appearing in your box plot, friends. So if you can see some points like this will be appear maybe outside the box. So we need to ignore these points because these are considered as the outliers. Sometimes we need to ignore these outliers because these outliers are not of much use for us. Okay. Sometimes there will be some hidden outliers also. Okay, we need to detect what are the hidden outliers, and we have to work on them. Sometimes some data is like that might not be an outlier, but still that will be like misprompting us, means like as a outlier. So all these things we need to look into. So when you are plotting it in terms of a graph, then only you can understand that if we have any outliers which are present in that, or else if there is any missing data, or else if there is any null data. So we have to take care of all these things. And when we are done with these things, then only we can apply the statistical models on the data set, and we can get some accuracy, friends. Okay. And yeah, let me show you one more example here, friends. I've taken the slices and I've given some values here. I've defined the data and I've given some apples, oranges, bananas, and I want to label them as the main fruits. And when I run this, you can see the beautiful pie chart is being appearing there. Okay, you can see how many oranges are present. It is occupying the more number of percentage. You can see that it is occupying the more area here, and apples, bananas, and other fruits. Okay, so that's what we are given here. So likewise, I can say this R programming is very, very good in the data visualizations. It is able to give you a very beautiful charts with different colors. We can change the colors. We can go with the different visualization techniques. It is very rich in the libraries compared to your Python. Okay. So as a researcher, if you want to go with much statistical values and you want to do more research, if you want to play with the data visualization techniques, I can say this R language is the best fit for you. This is the best fit for you. You can go with this R language. You can play like anything with the data visualizations here. And now, friends, it's already 1851 and that attendance sheet will might have been circulated in the group. Please fill up the form and fill it up. Okay, write your name and what is the required details, what you are supposed to give in the attendance form. Please fill it up and revert it back. So friends, this is about other different data visualizations what we have. And let me show you one more thing. So when we are working with a real-time data set, let us say I have a Titanic data set here, friends. So this data and how to load the Titanic data set, I have told you yesterday, like we have to give a read command. Okay, read.csv. So this is the command used for reading the data set into the memory. And when we read this data set and when you execute this, okay, in another page, you can see the complete data set is getting displayed. Come back to your R script here. Okay. Next thing is we are setting up the factors. What are the different factors we need? And just run this, friends. Okay. Now, if we want to plot the graph, the ggplot, okay, how many have survived? Just run it. So the count and the survived. Okay. So when you're looking at the count and how many people have survived, you can see the count here and how many people have survived. So zero stands for the count who haven't survived, and one stands for the people who have survived. Okay. And in similar lines, when I'm executing this, like here we are going with some labels. Okay. So in this case, what we have seen, add some customization. We have added some customization like survive plus the passenger count. Okay. So here we are going on the y-axis, we are taking the passenger count, and x-axis we have taken the how many passengers have survived. Yes, Prince, I think we have got a link for this attendance sheet. We'll be getting soon. Don't worry. We'll be giving you the attendance sheet. And now, friends, the second question is, what was the survival rate by the gender? If we want to go the survival rate by the gender, what we have taken here is, we have taken x is equal to, give it as a gender and just fill it with the survived. How many gender have survived? And here we are going with the geobar, means we are going with the bar plot. Okay. So here, each and every time we are going to plot it, we have to write there as ggplot, friends. Then only we'll be able to plot the graph. Okay. Just give me a moment. It's taking some time. So here you can see how beautifully it has given us the output, friends. Can see here the passenger count. So 0 means 0 and 1 here. Okay. And like if you're taking as 0 to be like not survived and 1 to be as survived. Okay. And if you're going as per that, and how many like female count, female has survived more compared to the male. If you can see here, the green. So more than 200, let us say it is around 230 or some people have survived more here compared to your male. So male passengers just survived maybe around 100 or 120. You can see the count from here. And most of the people, the majority of the people who were dead in the Titanic accident were drowned were more male passengers compared to female, because at the time female passengers were given the first priority. The women and the children were given the first priority. So that is the reason why more female passengers were survived. Okay. So if you can see here how beautiful it has got plotted. That is the beauty of your R language data visualizations. Now, third question is, what was the survival rate by the class of the ticket? So if you are going as per the class of the ticket, okay, if you're going as per the class of the ticket, how many people? Yes, we will be circulating, Shravanti, what we say, the attendance sheet. So don't worry. Anyhow, we are taking the online attendance, how many people are there in the group. So anyhow, we are monitoring them and we are taking a note of that. So don't worry. Anyhow, that is being getting counted. So soon we'll be circulating the attendance sheets, Shravanti. Now, friends, when you're talking about this, how many people have survived this Titanic, this Nisha? Let's, as per the class, let's have a look into this. So for this, what we have taken here, friends, the Titanic and we have taken X is equal to some gender. Okay. And here we are taking the passenger count and we are going to run this one. So friends, on each and every column, what it was present, okay, what it was present in this Titanic data set, we are going as per that. We have different columns, right? So each and every column we have to analyze. So how far you're analyzing, the better you analyze, the much you analyze, the better the results will be. So till now we have seen how many women and men survived this accident, this Titanic accident. And when you're now talking about the passenger count as per the class and as per the gender, see, that's what we have taken here, friends. When we are taking in terms of the class, okay, so this is representing that we are going with the column class, okay. And here we have assigned the X sum value as the gender, okay. When we are going to plot the bar graph, okay, geom underscore bar means we are going to go with the bar plot. So if you can see here, most of the female class in the female passengers from the class 1 were survived. They were given the much preference compared to the class 3. In similar lines, male people also in the class 1 were given much preference, and you can see the most survivors in the from the male passengers are from the class 1 compared to, and you can see class 3 also some male passengers survived, but the most less people who got survived were from the class 2. Okay. The less male passengers survived from this accident were from the class 2 only. Most of the people died here in the class 2. When you're talking about the male passengers. And when you're talking about the female passengers, more female passengers died from the class 3. So just by having a look at this diagram, friends, we are able to analyze. We got the insight. Inside that how many passengers survived and how many passengers haven't survived, just by looking at this picture. So that is what we say when we go with the data visualization tech, means when we are analyzing the data using the charts and maybe the bar graphs or whatever it is, you can get some idea out of that. Okay. So likewise, friends, we have different charts. We have different charts here. And when you are going with this, different bin widths. Okay, so you can see it is there is some skewness here, means there are some outliers also in this data. And last one is another great video for the question is box and whisker plot. So if you want to see how many outliers are there in the chart, can have a look at this. Okay, friends, if you can have a look at this, we can see that in this box plot, so these we have some outliers here. So these are counted as outliers. Okay, so by this box plot, we can analyze that there are some outliers which has to be ignored and which has to be removed from our data set. So once we remove this this outliers from the data set, our data set is clean and that is good to go. Okay, friends. So this is how we do the analysis, and this is how we transform the data, and this is how we go with the data visualization techniques. Got it, friends? So once we are done with all these things, we'll be applying this for statistical modeling, and we'll be getting out we'll get some accuracy based on all the models what we have applied. Okay, friends. So that is all about the R programming, friends. And I hope you might have understood what right from the past 6 days, it was very it was, I can say, was a kind of a privilege for me for taking up your classes, and I was very happy with your response. And let me thank you all for attending these classes very well. And just go through all these videos, friends. And if you have any doubts, you can post them in the comments. So we are here to explain your doubts through the comments. And friends, that's all for today. That's all about the programming part we have in the R programming. So friends, stay tuned to our 360DigiTMG channel, and we have much more much more YouTube programs which are coming up. So stay tuned to this. Have a great day. Have a great weekend. And bye, friends. I hope you liked my video. Thank you. Bye.